Thank you, and thank you all very much for coming. It's a wonderful day for an author when their book finally comes out, and today is the official release day for Growing a Revolution. So thank you for being here. You know, if you'd asked me 10 years ago when Dirt came out and I was standing up here talking about it, if I would write a trilogy about soil, I would have thought you were crazy. But looking back, I have. And I had really good help on one of those books from my wife, a co-author on The Hidden Half of Nature. And what I want to walk you through tonight is a bit of my journey through why a geologist would think to write a book about soil, why it is fairly important, and what led me really to write Growing a Revolution, other than this irresistible urge to write. It's kind of a, well, if of all the sicknesses one can have, it's probably one of the more productive. But what I want to start with is really a simple question. Which planet would you rather live on? Now, I'm sure there are an adventurous few who will answer the red one on the right, and if so, hey, go for it. I think we need to get there eventually. But I think most of us would pick that blue planet on the left, in part because of that color. It's blue because there's free water on it. It's essential to life. The other thing that's really essential and makes this a fairly easy choice for most of us is what you can't see. And that's the atmosphere. Earth has an oxygen-rich atmosphere. We need water and oxygen. Those are the two things that we would usually think of. But there's a third thing that's just as important in terms of supporting life on Earth, and that's healthy, fertile soil. As far as we know, Earth is the only planet anywhere that has soil on it because it is the mix of biology and geology. And as far as we know yet, this is the only planet with life on it. And it's a fundamental difference between Earth and Mars that makes our lives a lot more feasible. And yet soil is that one key resource that is consistently undervalued. It is under-recognized, and it is truly a strategic resource, every bit as strategic as things like oil, things like the nature of the atmosphere, things like rare earth metals for technology. Soil is a strategic resource when you think over geological timeframes and societal timeframes in terms of what it takes to actually support a complex civilization of people. We need fertile soil to do that. And soil degradation is a global problem and a very underappreciated one. And that's really the main reason why I've been writing a series of books about the problem of soil degradation, how soil fertility really works now that we understand more about the biology, and what it might take to actually fix the problem of soil degradation, which is really what Growing a Revolution is about. Soil degradation is an underappreciated crisis. How bad a deal is it? I'll just give you a couple images to get started on that. One is the UN map of soil degradation from a few years back. You'll notice that there's an awful lot of yellow and red areas on this map. Those are areas where our soils have been degraded enough to actually influence agricultural productivity, and it's painted in with a fairly broad brush. Fortunately, David Pimentel and his colleagues at Cornell a couple decades ago actually crunched the numbers and went through how much of the world's soil has been degraded by agricultural activity since the Second World War. And what they came up with is that some 430 million hectares of land around the world that was once farmed has been abandoned from farming due to soil degradation. That's an area that's equivalent to about a third of all present cropland. And if you looked at the problem of feeding the world, whether in 2050, 2100, or the real challenge of sustaining that off into the indefinite future, the way a geologist likes to think about things, having that 1/3 of the world's soils that have been degraded and taken out of agricultural productivity, having those back in production would go a long way towards solving the problem of feeding the world of tomorrow. And soil degradation is not just a modern problem. It's one that actually has deep historical roots. And that's what I explored in Dirt, The Erosion of Civilizations, that got me started on this soil trilogy. And that was a geologist's view of the problem of soil erosion as it influenced the course and fate of human civilizations, viewed through the lens of archaeology. And as it turns out, I was writing a history of farming, because farming practices were a major factor in the role of the soil degradation that influenced major civilizations around the world. And if you look into it and you look into the geoarchaeology, what was happening to the soils and what happened in terms of the archaeological record, you see a record of soil erosion influencing the demise of ancient civilizations around the world, from Bronze Age Europe, Neolithic Europe, Classical Greece, Rome, the southern United States, Central America, and many more that I documented in Dirt. And there was essentially a common theme that emerged from that. a theme that frankly I hadn't really suspected when I started looking into that book. And that theme essentially cast the plow as the villain in that book, because it was the development of the plow, that sort of most fundamental of agricultural icons, that really set the seeds for degrading the soil in civilization after civilization. And why would that be? Well, think about what a plow does. How many places in the world have you ever been where it was a natural grassland or a natural forest and you saw bare soil on the surface of the ground? Not many places outside of deserts have bare earth at the surface. Nature tends to clothe herself in plants. And what a plow does is it turns the earth over and disrupts the vegetative cover, and it takes some time for plants to come back in, for the crop to come back in and cover the soil back up. And in that window, if you get even a single major rainstorm, you can literally erode off a century's worth of soil formation in an afternoon, in an hour. It can happen in 10 minutes. And the basic problem with plow-based agriculture historically, as I looked at in dirt, was that it fundamentally changes the balance of soil production and soil erosion at the surface of the earth. And the soil is, like any other system, something that can be made and something that can be lost. And it's the balance between those competing processes that sets how much future generations will have. How important has that been in the history of our own country? Well, if we look at the eastern seaboard of the southeastern United States, one of the original bread baskets of North America after European colonization, you'll see that gray noodle runs from Virginia up there in the upper right down to Alabama in the lower left, and that's the Piedmont country, the upland hill country. And I've just given you one example out of the ones that I drew from dirt that motivated me in looking further into all this stuff. And what it shows is the magnitude of soil erosion since colonial agriculture came to this area. There's all kinds of reasons why colonial agriculture was so erosive, part about tobacco cultivation, part the story of the plow. But the key thing to notice here is that gray area is 4 to 10 inches of soil lost in a couple hundred years since colonial agriculture. The black areas are pushing a foot, about 10 inches. How big a deal is that? There was only 6 to 12 inches of black fertile topsoil across this whole region to begin with when European settlers landed in this region. In other words, in just 200 short years, and yes, as a geologist, I can say that, 200 short years, we had eroded literally almost all the topsoil off of a broad swath of the early agricultural engine that fueled the growth of our country. This shows you essentially a picture of what that looks like on the ground today. The soil over there on the right is from a tobacco plantation that's been in continuous cultivation for over a century. The soil on the left is a forest that had been cultivated but had been allowed to go back for a forest for about the last century. And you notice there's a slight difference in the color between the soils. The one on the right is sort of an anemic khaki beach sand-like deposit. It is very dry and blocky. The stuff on the left is full of organic matter. It's darker. It has a lot more carbon in it. It's much more fertile. It basically captures the difference of what conventional agriculture has done to soils across the eastern seaboard. The topsoil is just gone from that field on the right. The topsoil from the forest on the left is what really supports the productivity of that forest. Now, the problem of soil degradation is one that George Washington, among others in early colonial times, recognized as critically important for the future of our country, and as it turns out, I would argue, the future of our world. And in 1796, Washington wrote in a letter to Alexander Hamilton that a few years more of increased sterility will drive the inhabitants of the Atlantic states westward for support, whereas if they were taught how to improve the old instead of going in pursuit of new and productive soils, they would make these acres which now scarcely yield them anything turn out beneficial to themselves. Washington was a keen observer of the soil on his plantation, and he and others like Thomas Jefferson adopted crop rotations. They planted cover crops, but they still used the plow. And the significance of that comment will become apparent a little later in the talk. But they were very concerned about maintaining the fertility of their land because it was essential to their livelihood. And Washington was very concerned about the degradation of soils along the eastern seaboard that he saw happening in his time, because he thought that that would force American farmers across the Appalachians and to the west, not because of the concept of a manifest destiny. That came a century later. He thought it would happen because of soil degradation, and indeed that is what happened as people moved out of the seaboard in the early 19th century and helped go west. And in case The dirt book goes into more detail on all that. But if we turn back to our own state of Washington, there's an example here that is actually a compelling example of why a geologist would think that plow-based agriculture, what I would call conventional agriculture for the most part these days, is very destructive to the land. You'll notice that this is a wheat field out in the Palouse in eastern Washington. Now you don't see any wheat out there at the moment, do you? It's been plowed, it's a freshly plowed field. What you see are all those little channels, little rills. You could just plow right across them, you could erase them with the tractor quite easily, but it's soil that's gone missing. And if that happens year after year, and in a sustained manner, you can quite literally strip all the soil off a field. There's estimates that the Palouse has lost 50% of its topsoil in the last 100 years. In other words, we're repeating in the Palouse what happened on the eastern seaboards in the early days of colonial agriculture. What this photograph shows you is a fence. In that upper right corner is a fence that the farmer originally built around his water cistern back in 1911 when the field was first plowed. The only thing that happened in this field since then was it was planted in winter wheat using plow-based agriculture. And occasionally those storms would happen, those rills would come, remove soil, and you'll notice this cliff developed. And there's a little black line over there that I'll walk over and show you in a minute that shows you how that is a 1 foot increment on a survey rod that shows you how far down that soil has eroded in the 50 years between 61 when the photo was taken and 1911 when it was first plowed. And that is basically that. It doesn't show up very well on the negative, but it's a 1 foot increment on a survey rod. 5 feet of erosion in 50 years, that's about a foot every decade, that's about an inch a year. There is no place on earth that soil forms at a pace of an inch a year, with the possible exception of my wife's garden, but I'll get to that. So in researching dirt, I've compiled data on both the contemporary rates of soil erosion and long-term geological rates of soil erosion to compare with agricultural rates of soil erosion. And to make a long story short, I spent about a month in the library, compiled all the data I could get my hands on, and I've boiled it down to one table to spare you sort of all the details, and I'll show you the median, the average values for the different things that I'll show here. I'm not going to show you a whole lot of data tonight, but this one is important, because that red number is really different than those blue numbers. The red number is the average global erosion rate from conventional agriculture using plow-based agriculture, what we would call conventional today. The erosion rates for no-till agriculture are the next ones down in blue, erosion rates under native vegetation, soil production rates, the rates at which nature builds soils, and long-term geological erosion rates, which should match those soil production rates if the world was, on average, clothed in soil, which we perceive it to be, at least in the course of human history. So the big difference, the red number is a lot bigger than the blue numbers by a factor of at least 1 millimeter a year. 1.5 millimeters or so of erosion. Soils build at paces of 1/10 to 100th of a millimeter a year. So if you'll give me that difference of about 1 millimeter a year in the erosion rate off of conventional agricultural fields versus the rate at which soil is built, you can do the math on the back of a napkin and show that the soil loss of 1 millimeter a year implies you could lose 1/2 meter to a meter, 2 or 3 feet of soil, in approximately 500 to 1,000 years. And if you look back through the archaeological record, that's about the longevity of most major civilizations outside of major river floodplains. Why the exception of major river floodplains? Well, think about what happens along the Nile River, or the Tigris and Euphrates, the big rivers of India, the Indus and the Brahmaputra, or the rivers of China. Annual flooding delivers fresh silt to the floodplain every year, and the soil is built through the deposition of areas that had been eroded off other areas. Now think about what happened in Tibet as the silt all went to China, or in the Sudan and Ethiopia as it went to Egypt, or in the Zagros Mountains as it went down into Mesopotamia. Those areas were eroding and subsidizing the productivity of long-term civilizations in those floodplains. But this, of course, if you look at other civilizations that are in upland areas, like the eastern Piedmont, like the Piedmont in the eastern United States, you see a similar story of a few centuries of intensive farming, up to maybe 1,000 years of intensive farming, and the soil can literally be gone. You go to Syria today, you go to Libya today, you can find areas where there are Roman tax records that record great harvests off of areas where there simply is no soil. Think about that. Some of the world's major trouble spots are places where these problems were set in motion long ago. So the question obviously then becomes, well, do we have to repeat this at a global scale? I've shown you the data that suggests we are in the process of doing that, but do we have to? Is it inevitable? Is it a consequence of how we farm, or is it something that can be reversed? And what this picture shows you are my hands holding two soils that started out identical. The one in my right hand on your left of the screen is the soil that we started with in our yard in North Seattle when we bought a house in Green Lake and decided to make a garden out of it. The soil on the left is the soil that we have today in the yard. And it has basically gone from that light khaki, relatively infertile dirt to very rich, fertile soil. How did we do that? Well, that's what Ann and I describe in our book, The Hidden Half of Nature. And it relates a lot to that wheelbarrow down there in the lower right corner that she painted up with racing stripes. Because when we bought the house in Green Lake and we took the lawn off to try and actually plant a real garden, we found that we had dead dirt. We had glacial till, not a single worm. It was that khaki stuff I just showed you. And she decided that we really needed to add a lot of organic matter to the soil and to try and bring the biology back to merge with the geology and bring the soil back to life and life back to the soil. And that's really what she engaged in doing, and I encourage you to check that book out if you want the full story. There's a lot more there than I'll be able to go through in the next couple minutes here. But basically, her gardening activity rebuilt the soil in our yard. As I was writing the dirt book about civilizations destroying their soil over centuries, she was doing the opposite right under my nose in the backyard. And it took us a few years to really notice the magnitude of the effect. But what this shows you here is a pit that we dug in the yard about 5 years into the garden restoration effort. And her pruning shears are over there for scale. And if you look at the bottom of the slide first, that's the till soil that we had. It's basically harder than, well, it's basically nature's concrete. It's hard stuff. You'll notice that the plant roots go down to it and they don't go into it. They go sideways because they don't want to go down into that till. Notice all the leaves and the compost and the wood chips that Ann was layering on, mulching on the top of the soil. That was her primary restoration technique. Not disturbing the soil, but adding organic matter from the top. And notice there that we have about 2 inches of actually decent brown soil. It's gotten even better, much blacker as I showed you a moment ago since then. But within just about 5 years, we built about 2 inches of soil. That's actually incredibly fast in terms of how fast nature can build soil. And that started me wondering, well, could we actually rebuild the globe's agricultural soils, and how would we do it? What are the processes? Well, in looking at what happened in our yard, we started looking at what is known as the soil food web. What happens to all those leaves, those wood chips, the mulch, the composted coffee grounds that we added to our yard? They got added to the yard and are consumed by bacteria and fungi that break that material down, incorporate it into their bodies, and then are in turn grazed on by nematodes and protozoa and microarthropods, other organisms in the soil, that when they consume the microbes that were consuming the organic matter, they then excrete their waste products that are essentially a micro manure. They're essentially like livestock manuring the soil from the inside out. And microbes are incredibly nutrient rich because they've been grazing on things that were once living, and so they have a full complement of the nutrients and micronutrients that it takes to grow new life. And it turns out that the life in the soil is the engine that drives that recycling system. And so by restoring the carbon content of our soil, by restoring the organic matter, we were feeding the microbes that were processing that material back into the raw materials to build new plants. And it turns out that we learned something in researching the hidden half of nature that I was unaware of. Neither Ann or I had been taught this in soil science class. And that is that if you look at the zone of the rhizosphere, the zone around the roots of a plant, it's one of the most life-dense areas on the planet. It's like a little Amazon, a little Serengeti. But it's below ground, it's out of sight, it's out of mind. We haven't paid a whole lot of attention to it. But when we learned that plants will actually push out 30 to 40% of all the carbon that they fix through photosynthesis, they've got this monopoly on photosynthesis. They can make sugars. They push 30 to 40% of that out of their roots into the soil. Why would they do that? If you had nature's license to print money, would you then just go throwing it around? Well, yeah, maybe some of us would. But plants in general do this. And it makes no sense until you think about, well, what might they be getting out of the exchange? What are they doing? They're feeding the microbes that live in the rhizosphere, the zone around their roots. And those microbes, in turn, if they were doing things that harmed the plants, that would be an evolutionary dead end. It would not have come to characterize most of the plants on the land surfaces of Earth. So if you blow up that tip of a root and you look about what's happening in the root zone around plants, what Ann and I learned is that the rhizosphere is what we like to call a biological bazaar, where microbes and plants trade nutrients, metabolites, and exudates. In other words, there's that root coming down, the little purple area around it is the rhizosphere, that zone of microbe-rich life. The little red things are bacteria, the white strings are fungal hyphae that connect with the plant roots and go off into the soil. And those plant exudates that are pushed out of their roots, what are they? They're sugary compounds, they're carbohydrates, they're proteins, there's even some hormones that plants push out into the soil. They don't make it far. They make it a millimeter to a centimeter before they get eaten by all those microbes. And what do the microbes do with them? Well, what all organisms do. They metabolize it and they excrete something else. It turns out that that something else, the waste products from microbes, are things like plant growth promoting hormones. They're things that, to help the plant grow. And that's a virtuous circle where the plant is feeding the microbes and the microbes in turn are promoting the health and growth of the plant. And Ann and I go into a lot more detail on how that works, but that was a total eye-opener to us, because it explained to us how it was that adding this organic matter to our yard triggered such an explosion of life above ground in our garden that has brought us such joy over the last decade as it has evolved and literally changed our lives. And there's a lot more that we go into in that book as well, including the strong parallels between the microbiome of plants, the microbes that live in and around their roots, and the microbiome that we each have in our own gut. It turns out they're about the same system inside out. It's actually really cool. But we're not talking about that tonight. The last point I want to make on this before I really get into the meat on growing a revolution is that you can look at the way plants eat in two ways. You can think about it in terms of a fertilizer diet, where they're fed a major diet of macronutrients, things like the N, P, and K that you'll find on a fertilizer label. And what that does is it breeds plants. You can grow plants very big, but there's trade-offs in terms of their health. And what they'll do is if they are given what most of the macronutrients they need to grow big, they don't invest so much in a root system, and they don't invest so much in the exudates that would actually go out and feed those microbes in the soil. And what that means is that they're going to get a very little supply of beneficial microbial metabolites, those growth-promoting hormones and other compounds that the microbes are making with the exudates that the plants push out, and that microbes make with the organic matter that's in the soil. On the other hand, if you have a soil that is fed what Ann and I like to call the soil life diet, in a soil that is very rich in organic matter, that plant will be investing in its root system to actually put out exudates to try and feed the microbes that will break down that organic matter and trade compounds with the plant that benefits the plant. And it's a whole different deal. It will get an adequate amount of macronutrients. It'll get more micronutrients because the fungi are delivering the micronutrients to the plants. If you don't feed the fungi, you don't get as many of the micronutrients. And it turns out that if you look at what's happened to our crops in the last 50 years, the micronutrient concentration under conventional agriculture has gone through the floor. Dropped by 25% to higher than 50% in some of the studies that we reviewed. And in a soil life diet rich, in a life-rich, organic matter-rich soil, you get a lot of the beneficial microbial metabolites. Now, once we'd sort of seen the power of this kind of thinking for restoring our own yard, it brought up the obvious question of, well, what about doing this on farms? Could you do it on full-scale commercial agriculture? Could you do it in the developing world? Could you do it on major commodity crop operations in the developed world? And that's what really was the genesis for researching Growing a Revolution, where I undertook a trip of about 6 months' time where I visited farmers all around the world who were practicing what I call regenerative agriculture, and what others have called regenerative agriculture, the kind of agriculture that is embodied in that set of soil samples over there on the right-hand side of the screen. It's from some test plots at Ohio State University, where they've done a long-term study of different agricultural techniques. The soil on the left is essentially what you get by just going to no-till agriculture. The one on the right is no-till with cover crops and manure and a lot of organic matter added to the soil. And basically it was taken from very low carbon content to high carbon content, really fertile soil in a little over a decade. So how does this all play out? Well, we all recognize the problem that we're going to face in feeding the world by the mid-century to later of next century. That's one of the big problems that we face. And it's a fair question to ask whether or not the 20th century strategy of intensifying fertilizer use is actually going to be up to the task of maintaining, let alone increasing, agricultural production over the course of the next 100 years. Because how many people think that the price of oil and the price of fertilizer that's primarily manufactured using oil is going to go down over the next century? Only one person has ever raised their hand when I bring that up at a public lecture. We're burning through our supply of oil, and yes, there are other fossil fuels we could use, but no, if we went to relying on coal, the climate is going to get us in the end. So, we really have to rethink our strategy of relying on fossil fuel and nitrogen fertilizer intensive practices to maintain our crop yields if we're going to have a prayer of feeding the world in the future. And that brings up the question of whether, how could we rebuild soil fertility? Because it would be really useful for rebuilding all that degraded agricultural soil we have in the world when we're thinking about how we're going to feed a post-cheap oil and fertilizer world, whether that happens in 20 years, 30 years, or 200 years. To a geologist, those are just different, they're almost the same. It's only a 1-0 difference on the end. But the question is really, how are we going to keep feeding 9 or 10 billion people beyond 2100? It's not just how will we feed people between 2050 and 2100. How are we going to keep doing it? And that leads me to think that we really need to think about ways to generate a different kind of agriculture. And I came to see the feasibility of a greener kind of soil health revolution in terms of agriculture. We've had a number of agricultural revolutions throughout history, and what I'm basically arguing in Growing a Revolution is that we're poised for another agricultural revolution, but this one's centered on soil health, a fundamentally different concept through which to approach farming practices. And many people and many farms in the world are already doing this. This is not a terribly original idea. I'm not claiming credit for that. But I will claim credit for having gone to visit some of the people who are actually already doing it and trying to look for the common elements about what made it successful. Why was it working in the kinds of farms that I was looking at? And what I basically came away with is that adopting the principles of conservation agriculture can actually revolutionize agricultural production and take agriculture from what is essentially today an environmental problem maker and turn it into a major environmental solution. And what are those principles? Well, to let the cat out of the bag, it's these three ideas right up on the screen now. It's minimizing soil disturbance, which is the direct planting of seeds, which include no-till agriculture. Basically, the idea is that if you are disturbing the soil through plowing, you're not only leaving it bare to erosion by wind and rain, but you're also chopping up the mycorrhizal fungi, you're basically stirring up the soil ecosystem, you're compromising its ability to actually engage in that nutrient cycling that you can use to grow the next generation of plants or crops on a field. It involves maintaining a permanent ground cover. Don't leave the soil bare. And that means using cover crops, planting things in between your commercial crops, planting things even in between the rows of one's commercial crops, and including legumes in one's crop rotation in that idea is a good one because they can fix nitrogen and help replace fertilizers, as I'll go into, and diversifying crop rotations to help maintain soil fertility and also break up pathogen carryover. If you plant corn after corn after corn crop in the same field, what you're really doing is you're setting a banquet table for pests for corn, sending out advertisements on billboards, and then almost paying them to come. On the other hand, if corn pests that sort of colonize a field one year, if their eggs hatch in a field that's then planted in barley or then planted in something else, they don't have stuff to eat. So these three principles, minimizing disturbance, including cover crops, and diversifying crop rotations, are the three principles that were in common in the farmers that I visited around the world. So I'll share with you a couple thoughts on some of the farmers that I visited. I'm not going to be able to describe all of them. Most of the farmers I visited were intentionally conventional farmers who had decided to change the way they farmed. Only one farm that I went to was an organic farm. One was an agroforestry operation in Costa Rica. I won't tell you much more about that one, but it was really cool. But this gentleman, Dwayne Beck, runs Dakota Lakes Farm in South Dakota, and the reason I chose him was A, he's charismatic, and it was good to write about. B, he's radically transformed the area that he's worked in, and C, his area in South Dakota is from the area with the cover picture of my book Dirt. That was a poster child from the Dust Bowl. He took me on a 300-mile driving tour in the area around his demonstration farm, and I saw 3 plowed fields. And it's mostly due to his efforts in terms of showing farmers that there's a different way to do stuff with no-till agriculture, and then working to develop techniques that would work for them in their setting. And he's basically solved the problem of erosion in that area. And I was flabbergasted. It was an amazing, they've done amazing work there. So what has it done essentially to, they've adopted no-till cover crops, and they've adopted complex rotations. What this has allowed them to do in rebuilding the fertility of their soil is they've greatly reduced the amount of diesel that they use, because if they're not plowing, they're driving their tractors across the fields less. They've cut their diesel by half or more. They're using less fertilizer and far less pesticide. He hasn't used pesticide, as if I recall correctly, in a number of years at all on his farm, and they're using just a small amount of fertilizer relative to what they used to. And what's happened to their crop yields? Well, using their traditional methods, they've gone from 63 bushels an acre of soybeans up to 79 bushels an acre using these techniques. In other words, their yields didn't go down by adopting this more environmentally friendly farming. They went up. And the corn did the same thing. And this is on a major commercial operations on large farms in South Dakota. I also went to farms in Africa. And the gentleman I'm showing you here, who has that wonderful hat of "Got dirt, get soil," that is the right idea. Transform your dirt into soil. And Kofi Boakye here is essentially a man who's on a mission to do that in Ghana. He has worked with farmers in the village, in his village in the area near Kumasi, to transform the agriculture that they had from their traditional form of agriculture into one that involves those 3 principles. And they'll have a polyculture. Here you can see plantains with peppers underneath. Notice there's no bare ground. There's the remains of last year's crop on the ground as a mulch, in effect. And what Kofi has done is, the farmers that he works with are not people that you could ever realistically, in the short term at least, imagine that bringing the green revolution to Africa would actually help feed. Why not? Because they don't have money to pay for the fertilizers, to pay for the GMO seeds, to pay for herbicides. They're not organic farmers, but they are resource limited in terms of the capital that they have. Their primary asset is labor. And what Kofi has done is he's basically shown them ways to transition from their traditional slash and burn style of agriculture to a style of no-till agriculture with cover crops that has diverse rotations and multiple crops in the same field. Some of them have up to 8 crops in the same field at one time. And you might imagine that might be a little difficult to do with mechanical harvesting, but it's feasible to do with manual harvesting. And so what's happened to their productivity? Well, first of all, look at the numbers for the erosion rate up there. Under the traditional slash and burn, they lose a lot of soil. And how does slash and burn work? Well, you cut the forest in one area, you harvest it for a year or 2, then you move on to another area, and you let the jungle come back and restore fertility before you come back to the area that you did before. How does that work when your population gets big enough that you have to farm everywhere every year? It doesn't. What they get is huge erosion in that case. His no-till system has cut erosion almost down to background rates. And notice also what happened to their crop yields down there. The traditional practices were yielding 1.5 tons of corn per hectare. With Kofi's methods, they're getting 4.5 tons per hectare. Tripled. The cowpeas doubled. What he's managed to do is, without increasing their use of agrochemicals or inputs, he's managed to greatly increase their harvest by fundamentally changing their philosophy and practices to adopt those 3 general principles, and he's leapfrogged from their traditional agriculture right past what we might call modern conventional agriculture into conservation agriculture. And in his village, when he started, nobody owned their home. Now they all do. You walk through the streets with Kofi and everybody knows him. a very inspirational visit to a very inspirational man. And these other guys that I'll show you here, the other two farmers I'll talk about tonight, and I talk about a few others in the book. The guy on your left is Gabe Brown, and he's someone who's a cattle rancher and farmer in North Dakota, and he's basically restored his prairie soils using cattle as one of the main catalysts for change. Because just the way you can apply those three principles of regenerative agriculture for cropping, there's other ways to think about how one actually runs cattle. And in my PhD work, I worked on the erosion of gullies in the California coast ranges and showed that Spanish dairy cattle caused a lot of the big gullies because they always let the cows hang out by the creeks where the water was, and so the cows were always there. What Gabe does is he basically moves his cows around a lot. He follows the practices of what the buffalo, the style of grazing that the buffalo practiced, which was clumping up in a herd because the wolves were out and grazing intensely on an area, but always moving, and then once they'd grazed an area, they wouldn't come back for a year. So it was high disturbance, low frequency grazing. And that's what Gabe is practicing on his ranch, and what Neil Dennis, another Saskatchewan cattle ranch that I visited, were doing. They've managed to almost greatly increase their stocking density while restoring their prairie soils, and as a not unrelated restoration, they've restored the prairie vegetation communities on their fields. The guy on the right is David Brant. He's an Ohio commodity crop farmer who is showing off one of his daikon radishes. He grows them to till his fields. He was actually quite surprised when I told him what we might pay for that daikon radish in a farmer's market in Seattle. Why does he grow radishes? It's a cover crop. He plants them in between his corn and soybeans, and he lets them dig down. You know, they have this great taproot that goes down into the soil. When he first got his ranch, it had bad soil with about 0.5% to 1% of organic matter. It was hard. Those radishes help actually break it up. Now he loves them because they grow big, they take nutrients from deep in the soil, bring them up into the topsoil, and then he lets them rot. He just like mows them down and lets them rot in the soil, and they form little pockets of nitrogen and phosphorus-rich fertilizer, biological fertilizer, that then helps his subsequent crop grows. He's been no-tilling since he came back from Vietnam. He was in the Marine Corps in Vietnam in the 1960s, and he came back and started no-tilling in Ohio then. So he's been doing it for about 44 years, and the transformation he's made on his soil is absolutely astounding. You put a shovel down into his soil relative to his neighbor's farm, which he actually just bought, but that had been conventionally farmed for as long as, well, for probably about a century. And it's like night and day. Same soil, same climate, same crops have been growing, different style of management. And it's way more profitable what he does. So if you compare Brant's activities at the Brant farm in Ohio to the county average was about full tillage, using about 200 pounds of nitrogen fertilizer per acre and 2.5 quarts of Roundup. The total cost for doing that was about $500 an acre, and the county average 2 years ago, when David was reporting this to me, the corn yield average is about 100 bushels an acre. That means that farmers in his region lost $100 an acre for everything they planted. They lost money working hard. When I was researching this book in the final stages, I ran across a paper from Iowa in 2015 that reported that 25% of the farmers in Iowa lost money on every acre they planted that year. Their input costs were higher than they could get for their corn. What that reflects is that modern conventional agriculture has gotten so good at growing commoditized crops that it's driven the price of those crops down, but the methods that are being used to grow them depend on inputs that are based on fossil fuels, the price of which have been going through the roof. And the companies on either end do just fine. It's the farmers that are squeezed in the middle. And to me, that's the big sort of untold story of the demise of family farms in America, is that we managed to convince farmers to farm in a way that decades on, they're squeezed and it's being balanced on their backs in the middle. So Brant was mostly interested in, well, how can he lower his input costs? And by restoring his soil using those three principles of regenerative agriculture, and to be fair, all these people I've been talking about started with no-till, then they added the cover crops, then they diversified their rotations. They've gone through the learning curve to figure out how it works, and one of the reasons for writing a book like this is to try and share that information and vision so that every farmer doesn't have to relearn over the 20 years it took them to figure out the techniques. So on Brant's farm with 44-year no-till with cover crops, he's not tilling at all, so he saves on his diesel straight away. He's only using 24 pounds of nitrogen an acre, about 12% of what the county average is, and he uses a quarter Roundup an acre. He's not an organic farmer, but he's pretty darn close to it, and I like to call him organic-ish. And that was an acceptable term to the farmers that I was talking with. Not everyone wanted to be called an organic farmer when I said, look, you're just not using much inputs. Why not just not use any and take the price premium? There's a whole lot of issues involved. Some cultural, some economic. But Brant, his total cost per acre was $32. His yield was better than the county average substantially. And at $4 an acre, at $4 a bushel, he was making $400 an acre. He was quite profitable on his farm. He was spending less to make more. It makes a lot of sense when you look at it that way. So what are the benefits of conservation agriculture, of adopting these three techniques and playing them out over years? Comparable or increased yields. I didn't visit a single farm where someone who had adopted all three of these techniques found that their yields went down, other than in the 2-year to 3-year transition period, where if they had land that had been conventionally farmed for decades to a century, they had to start rebuilding the organic matter in the soil before they would actually see the benefits of adopting these techniques. So there's a transition period, but I was shocked at how brief it was. It was 2 or 3 years. Now, to get the full performance that Brant was getting, he's been doing it for 44 years. His soil is amazing. Gabe Brown's soil is amazing. But that can be done, and it can be done in decades, not centuries, that a geologist would have thought that it would have taken to rebuild fertile soil. They greatly reduced their fossil fuel and pesticide use. They increased the amount of carbon that's stored in their soil, and that increased their crop resilience as well. The amount of water that they can hold, that the soils would hold, was greatly increased over conventionally tilled soils. And why? Well, a life-rich soil that has lots of worms, lots of fungi, lots of structure to it, when rain falls on it, it'll sink into the ground and get down where you want it for crop roots. If you continuously till the soil and you break up that structure, the first time it rains, you get a crust on it, and the water runs off into a river or stream. It doesn't, as much of it doesn't actually make it into the soil. You can park so if you think in terms of climate resilience, actually, that's a very effective way to build it. And obviously, the thing that would be of great interest to most farmers is that every farmer I talked to that had adopted these practices had higher profits than their neighbors because they were maintaining their yields while spending less on inputs. And so one of the things I learned in researching this book is that the real question, I think, about the future of agriculture isn't so much the question of sort of low-tech organic versus GMO and agrotech, the way that the mainstream media tends to portray things. But it's a real question of how to apply an understanding of soil ecology to the problem of increasing and sustaining crop yields in a post-oil environment. Some of the farmers I visited were very low-tech. Some of the farmers I visited were really high-tech and had GPS devices on their giant prairie crawler planters, kept track of everything they put on every square meter of their farm. It's not really a question about technology. It's a question about the philosophy behind which one is approaching farming and how one is actually using the technology at our disposal. In terms of the carbon sequestration potential of soil restoration, there's a lot of interest in that, and it's very well-placed interest. Frankly, I found that the estimates for how much carbon we could park in the world's agricultural soils should we adopt these practices and regenerate fertility were all over the map. They ranged from, at the low end, Rattan Lal's conservative estimate that we could offset about 5 to 15% of global fossil fuel emissions if we adopted these practices, up to the Rodale Institute arguing that we could fully offset fossil fuel emissions through regenerative agriculture. The point that I would like to make is that we should be doing this style of agriculture whichever end of the spectrum plays out in terms of the carbon game. And we should be encouraging farmers to do that. The carbon sequestration benefits you could think of as a bonus. I mean, we need to do this to maintain the fertility and the yields that we're going to have into the future. And we should put more research into figuring out the carbon angle and investigate it. But the same practices you would use to restore fertility to the soil are those that will build carbon in the soil. So I'd like to argue that the future of agriculture is really rooted in soil health. We need to rethink the way that we look at soil and approach the practice of farming and use the insights of soil ecology to restructure agricultural technology focused on building soil health to enhance ecological processes and nutrient cycling. And that's a fairly different way to look at it than the conventional versus organic dichotomy that we're used to thinking about. And I think that if we were able to convert conventional farming to this more conservation agriculture-oriented farming, it would move conventional farming to so close to organic-ish that the difference between organic and conventional would become much narrower than it is today, and the arguments, therefore, would be kind of less heated. And this is my favorite quote from Leonardo da Vinci. I had to put it in here somewhere. We know more about the movement of celestial bodies than about the soil underfoot. Sadly, that's as true today as it was 500 years ago. We talk a lot, Ann and I talk in the Hidden Half of Nature a lot about the recent discoveries in terms of microbial ecology in the soil, but we are literally on the frontier of just understanding who's down there doing what. So how would we promote soil health? Academics will argue for the next decade about how to define soil health. But I would argue to you that it's something that you kind of, if you see it, you know it. It's kind of like our own health. We know if we're feeling healthy or if we're feeling bad. You can tell the same thing with the soil. How to actually promote it? Well, there's a few simple ideas, and a geologist may not be the right person to identify the right policy levers to actually move the ball down the field. But reforming crop insurance and our subsidy programs, we're basically paying farmers to destroy their soil these days. This is not good long-term social policy by any stretch of the imagination, and those programs really need to be reformed to try and reward farmers who are engaging in practices that build and sustain the fertility of their soil. We could use more demonstration farms like Dwayne Beck's Dakota Lakes Farm, like Kofi Boakye's No-Till Center in Ghana, showing farmers a different way to do it because you're doing it at full scale on a farm and showing that it works is a really good way to get the word out. And we could also provide assistance for that transition between the 2 to 3 years that it takes to convert methods. We should be backstopping farmers who are adopting the methods to regenerate the fertility of their soil. And one of the odd things that I ran across in researching this book was something about the intellectual godfather of the fertilizer industry. This is Justus von Liebig, the guy who sort of realized that if you added certain chemicals to a soil, it could boost plant growth. And he posited the model, the so-called leaky barrel model over there on the right, that if you think of a soil as a leaky barrel, if whatever the nutrient that's in the least supply relative to the plant's demand for it, if you add more of that, you can get more plants. And that's really what led to the explosion of phosphorus and nitrogen fertilizers in the 19th century. What I didn't realize is that he wrote another book in 1863. That first one, where all his ideas about fertilizers came out of, was written in the 1840s. Near the end of his life, at the end of his career, he wrote another book that he basically revised his view on how farming should be done and argued that returning organic matter to the fields was necessary to provide crops with the full complement of nutrients. In other words, he recognized that if we just give plants nitrogen or just give them phosphorus, we're only feeding them a portion of what they need to be healthy. They need the full spectrum of nutrients and micronutrients to be healthy. And he argued quite passionately that we had to return urban sewage to the farms from which the food was grown to actually close the loop in terms of nutrient cycling. It's a view that actually was very, was 100 years ahead of his time. But this is the intellectual godfather of the fertilizer industry, basically at the end of his life realizing that, no, maybe this is not such a good idea to rely on just a couple elements to spur crop growth. And the point that I want to make is that we are basically at a place where we need to think about soil differently. In the 20th century, we often thought of soil as a cheap industrial commodity, the cheapest input to farming. And what do you do with the cheapest input to any industrial process? You're not going to be worried about conserving it. You're going to use it up because that's the cheapest input. We need to see soil differently. We need to see it as a long-term intergenerational resource to be shepherded and stewarded because the future will depend on it as every bit as much globally as the future of modern Syrians and Libyans depended on what was done a couple thousand years ago in their countries. So we need to see soil as an ecosystem to be understood and worked with, not something to be managed or worked against. The idea of cultivating the beneficial life in the soil so that we can enhance the cycling and fertility that's happening there and then harvest crops from that is a whole different philosophy and way of looking at farming. And those three principles of minimal disturbance, cover crops including legumes, and a diverse rotation, those principles are essentially aimed at cultivating the beneficial life in the soil that will rebuild fertility. Now, why would we want to bother going about this at a global scale? As I argue, the examples that I go through in Growing a Revolution demonstrate is feasible. Well, I can't name any other single act that would help with all four of those problems that we face up there on the screen today. But restoring fertility to agricultural soils would help us feed the world of the future in the post-cheap oil and cheap fertilizer world. It would help us address the problem of climate change by increasing the reservoir of carbon that we can sequester in the soils. Now, carbon we put in soil doesn't just stay there, it turns over, but you can think of it as a reservoir. Same way that a water supply reservoir has water flowing into it and flowing out of it. The soil has organic matter flowing in and flowing out of it. The trick, I think, in terms of carbon sequestration is to increase the reservoir capacity of our soils so that there's more stored in there at any one time. Restoring soils will help with biodiversity and environmental degradation. Everything, if we could reduce our reliance on nitrogen-based fertilizers, as these techniques allow us to do, it would greatly decrease the amount of nitrate pollution in human water supplies in agricultural regions, and also help address that great dead zone in the Gulf of Mexico due to fertilization in the Mississippi Basin. And if you think about the biodiversity on Earth, we use about a quarter of the world's land area to feed ourselves. The future of biodiversity on this planet is intimately tied to the future of farming, how we farm. And if we can use fewer pesticides and herbicides, we will have more life on our farms. And it can also restore profitability to family farms. So frankly, I don't see any reason why we should not be embracing these ideas full hog at a societal level. Well, there's some obvious impediments in terms of perhaps some people manufacturing inputs that wouldn't be used as much under these techniques might have something to say about that. But I can't see any real rational policy reason not to support moving in this direction. And I would like to thank you all for your attention. That's really what I wanted to say. I had not thought that I'd ever write a trilogy starting when I started writing Dirt, but we've got through it, so I guess I need to do The Hobbit next or something. And I also want to thank my wife, Anne, for helping write the middle volume in this. Her insights are absolutely essential to figuring out the stories in there. And we've dove into the world of social media. If you want to follow us on Twitter or check out our website, we invite you to do all that. And of course, I'll invite everyone here to get a copy of the book, read it, share it, review it on Amazon, get the word out. I think this problem of soil degradation, despite being one of the really big ones we face, this one is fixable. Because if farmers can make a better living doing things that are better for the environment, we should all be trying to help them make that transition so they can be prosperous and profitable. And the next project Ann and I are thinking of working on is looking at the nutritional differences in the quality of the food that's actually grown using those techniques. Because we suspect that it's a big story, but it's one that there's not a whole lot of data we can find yet, so we're going to dig into that. Anyway, thank you very much for your attention, and I'll be glad to entertain a few questions.
So we have time for just a couple questions. If you do have a question, we ask that you come up to the microphone on either side of the stage so everyone can hear you. And please remember to keep your question in the form of a question. Thank you.
So Paul, you get to go first.
Thank you. It's really great to see you again.
Thank you.
How can science reliably validate mankind's incremental contribution to climate change compared to prior changes over deep history?
Oh, in terms of, well, I mean, you can look at the long-term CO2 concentration in the atmosphere, and we're at the point now where it's been, hundreds of thousands of years, as far as I recall, since we've been at that level. If you really want to look at, there was a study back in 1978 that was done by Minza Stiver at the University of Washington. He was a carbon isotope guy. And he did a study then that documented that about a third of the CO2 that had been added to the atmosphere since the Industrial Revolution came from plowing up agricultural soils. So you can look at you can start to parse out how much came from fossil fuels, how much came from land management. And you can look back in ice cores in terms of how much CO2 has been in the atmosphere at any one time. And we're going into uncharted territory for the existence of our species as an agricultural dependent species. You know, the temperature in CO2 through deep time has, you know, varied greatly from the hypothesized snowball Earth, where, you know, the Earth almost froze over, to the really hot times before the evolution of the grasslands, which is thought to have drawn down atmospheric CO2 by increasing the carbon content of the world's great soils that we've now undone by plowing them all up. But I would argue too, there's actually a pretty good handle on what the human contribution is today to the change in CO2. What there's a far less of a good handle on is what's going to actually happen if we go back into some of that high CO2 terrain that has been around in some periods in the geological past. What does that mean for the biology on the planet, including us? That's a much bigger open question that, you know, some of the potential answers are pretty scary. Pardon? Oh yeah, and I've got colleagues across the hall who are doing a lot of the ice core work. Yes. Yes.
Hi, I was wondering if you've approached any like farmers union, any of the lobbyist groups for farmers and for the chemical companies. Do you know the process that presenting this information to them? Any feedback on that?
Well, the book came out today, so they're probably not aware about it. I expect that there are some people who will be really excited about it and some people who will be really quite mad about it. Or, you know, one of the things I did in addition to visiting farmers was to look in the scientific literature about, you know, what kind of studies have been done that back up some of the things that they're telling me. How can I triangulate that stuff? So I tried to do due diligence in terms of the feasibility. One of the key things, though, is that there's been very few studies of the effects of a system of conservation agriculture that involves all three of those elements. There's a lot of studies that just look at no-till or just look at cover crops or just look at the rotations. So getting the hard data to actually be able to forecast how big a change would it be, it's a bit tricky. In terms of the whole lobbying thing, no, I have not talked to farmers unions. I've talked at many farming conferences. But you know, the farming conferences I've been speaking at are the no-till conferences and the conservation agriculture conferences. But every one of those I go to, there's a mix of people who are just seeing these ideas for the first time. And I was actually really impressed with the community of farmers who are really pushing on these ideas. And it seems to me to be really a ground-up, a bottom-up effort, because they've seen it works on their land and they don't have anything to sell. They're just telling people what worked for them and trying to share that information. Many of them because they really are concerned about the state of the land. When I first went to talk about farming practices after having written Dirt, I was afraid I'd be run out of town for, you know, saying that the plow destroyed civilizations. And I was really surprised by how many farmers stood up and said, I've seen this, how many elderly farmers stood up and said, I've seen this over the course of my life. You're actually right. And so I think there's actually a lot of common ground that could be had between sort of people in the fortress blue cities of America and the broad swath of red across the heartland. I think we really should be able to unite behind the idea of restoring fertility to our soils, because everybody will benefit from it. Well, almost everybody will benefit from it. Most people will benefit from it. Yes?
So my first question is, I guess, sort of a fun question, which is, where's the dog?
Oh, he's at home.
Oh.
Yeah. He's doing well, though. Thank you.
Okay. I figured he'd be lonely. And the other question...
He's taking a break from us.
The other question is, has any of the stuff that you've been talking about contributed to the fact that in like 68 or 69 years, Israel went from a desert to a fertile land?
You know, I would have to visit and know more about Israeli agriculture to give you a very good answer to that. I know that was it Daniel Hillel and his drip irrigation system really worked wonders. I mean, shepherding a water supply in a very rational way, to my thinking, is one of the things that Israel has done incredibly well at. And I have not visited, and so I can't really give you a solid take on whether they've adopted these principles or it was mostly the figuring out how to irrigate in a very efficient manner that really did that.
Okay, thank you.
Thanks.
Yeah, I'm wondering how the petrochemical industry and the agricultural colleges and let's say an organization like the Gates Foundation is intersecting with this kind of information. I know it's a very fresh book, but it's a subject that's been around for a while. I see them as real obstacles, and I'm just wondering what your hit on this is.
Almost every farmer that I talk to, and I ask them the questions of, what are the opportunities and what are the impediments to implementing these ideas, they all pointed at the land-grant college system. They all pointed at university research as in agriculture as dominantly focused on individual elements and products rather than rethinking the basic philosophy and system at a farm scale. So I think there's a lot of room for academic research to shift and change to support this, and I'm starting to see evidence of that. I know of colleagues, I'm going to be out at a soil ecology conference in Colorado in June that are very interested in the book with people who are doing studies that are looking at exactly these kind of issues. So I think the farming community that is pushing these ideas is way ahead of academic research in general. I think that you're likely to see that any industry is not necessarily going to be look that favorably on ideas that require the use of less of their products. So I think you can expect resistance from that corner quite rationally. I would love to think that the USDA will start getting on board with many of these ideas. I think that there's problems in terms of who advises them. There's problems in terms of how their programs are set up. The Natural Resource Conservation Service has started a major soil health oriented push, but as one of their leaders admitted, they need to retrain a bunch of people. It's a different way of thinking about the problem. And I forgot the third question. Oh, the Gates Foundation. Yeah, the Gates Foundation. Well, if anyone here is from the Gates Foundation or knows the Gates Foundation, and if they'd like to talk to me about the book, I'd be delighted to talk to you about the book. I went to talk to them once about the dirt book that I was 10 years ago, and it was a little off topic at the time for what I think they were interested in. But I think there is huge room for philanthropic support for these kind of ideas. Kofi Boakye's farm in Ghana, for example, was set up with funding from the Howard G. Buffett Foundation. And I think the idea of establishing demonstration farms in the developing world for how to use these kinds of techniques that are low input to raise output are exactly a very good way to go. And I'd be happy to talk to anybody, including the Gates Foundation, about the wisdom of that. The basic idea of bringing a green revolution to Africa doesn't work for subsistence farmers who have no money to pay for the inputs in the first place. And I wrote about that in the Dirt Book 10 years ago. I believe that just as much today after having visited them as I did then. I think if we really want to increase the productivity of subsistence farmers in Africa, we need to basically try and work with things that work for them. And for these farmers in rural Ghana, what Kofi was doing was exactly the recipe. He was from that village, he was a farmer, they're using hardly any inputs, and their outputs have gone way up.
We have some time for these last couple questions.
Helmut.
Hi, how are you?
Good. Yourself?
Good. How do you view the use of animal and human waste in restoring soil and helping productivity?
Well, there's a chapter in the book that looks at animals in terms of Gabe Brown's farm and a farm in Saskatchewan, and how I view that now is a little different than when I started writing the book, because I viewed cows, when I started writing the book, I viewed cows as an agent of erosion and destruction. It all depends how you run them. It all depends on how you graze. And so I'm firmly convinced now, having seen what these guys have done on their ranches, that it's possible to raise large numbers of cattle in ways that actually regenerate the ecosystem. I would never have told you that 10 years ago when I was writing dirt. So researching this book changed my view on that. In terms of human waste, in one of the chapters I describe a visit to the city of Tacoma's sewage treatment plant where they produce a product called Tacoma Grow. It's made from the stuff that people in Tacoma flush down into the sewers, and it goes to the sewage treatment plant. And they've turned their sewage treatment plant into what they like to call a soil factory. And they're basically making humanure, and it is incredibly fertile. They have dealt with many of the problems that you might imagine could be in that through pre-treatment. Got the heavy metals out of it. And the process that they go through of both anaerobic and aerobic digestion means that everything in it has been eaten several times by the time it comes out the end of the plant. And you know, if we look at the long term, the wisdom that Liebig was arguing, that we need to return human waste to the fields, there's a certain wisdom to that in terms of closing the loop. On the other hand, if you basically run the numbers, it's not enough to actually fully offset our use for fertilizers. But if you take all the cattle manure in the country, and if you, instead of concentrating that in large confined animal feeding operations, if instead you distributed those cows over farms across America, or if you somehow composted all that stuff from the capos and distributed it, but that has whole other problems with it. But there's enough cattle manure produced in this country to fully replace all the fertilizer we use on corn. So, I mean, we're basically, the basic idea that we're treating these organic wastes as waste instead of something that can be fed to the microbial world and recycled back into the raw material for new life. And where that's particularly going to come to a head, as I talk about in Growing a Revolution, is with phosphorus. You know, we can get more nitrogen and carbon out of the atmosphere. Phosphorus is a whole different deal.
GrowCo is the King County version.
GrowCo and Loop?
No, GrowCo is like the Tacoma thing.
Okay. Well, yeah, but no, I had a nice tour through the Tacoma plant. I haven't seen the King County one yet.
Do you know of any organizations that are doing any like grading or labeling of regenerative practices? So as consumers, we could, you know, instead of looking for organic label on packages, look for something that was a little bit more.
Start one. No, I do not know. That's one of the things I write about in the last chapters, that I think that would be very useful, because there are, I mean, if you look at organic agriculture, there's a huge spectrum of practices, just as there is in conventional agriculture. But I don't know of a single label, a single point of purchase identification that one could do for looking at that. There's groups like Shepherd's Grain that are looking at no-till, and you know, things that are labeled as regenerative. You'd want to know, well, what is the standard? How could you do that? I think an organization to do that, sort of a consortium of small farmers, might actually be a really good idea. But no, I do not know of one.
Okay, thank you.
How dependent is no-till on Roundup, and how effective will Roundup be if it's so widely used?
Oh, it's a great question. One of the big criticisms of no-till agriculture is that, as it's practiced primarily in North America, is it uses a lot of Roundup, a lot of glyphosate. And why is that? Well, consider why people, and then I'll get to your question too, but consider how people, why did people use the plow historically? It was a great weed control. So when Monsanto invented GMO crops, it allowed, well, the glyphosate-resistant GMO crops, it allowed using a lot of herbicide to kill all the weeds, and then the only thing left standing would be your corn, which was very convenient and was widely adopted. It had a whole lot of other downsides associated with it too. We talk a little bit about that in The Hidden Half of Nature, and we're going to be looking a lot more into that in the book we're thinking about writing. But so the key question that I wrestled with in Growing a Revolution is herbicide necessary for no-till? And the short answer is no, it's not. I've been to farmers who aren't using it and are using no-till and are very successful. So there are ways to do it, but what it means is that they need to have alternative means of weed control. And what they do is they'll use cover crops to basically outcompete the weeds. So basically, if you plant a cover crop at the same time that you plant your main crop and it comes up before the weeds do, basically you can shield them out and you can outcompete them. And then they will also take, if they then knock their weeds, some of them actually think of weeds like, well, they're fine, they're like a cover crop. And they kill the weeds with a crop roller ahead of their next planting, and they turn the weeds into mulch. So they kind of recycle them. But the conventional wisdom you hear is that no-till is highly dependent on herbicides. And that is true as it has been generally practiced. But it is not necessarily the way one needs to do it. And that was one of the key questions I wanted to ask in researching this one, because that's a big one. Yes?
Thank you for all your good work on this critically important topic.
Thank you.
I'm interested in biochar. Could you say a little, this may be a little off your three main threads here, but can you say a bit about where you see it, particularly in its wonderfully paradoxical value, or if you think so, in arid regions, given where it originated? And do you see a problem? Do you see its application at scale?
The question of biochar is one that in the book I wrestle with by going down to Costa Rica and visiting farms in the tropics who are using biochar to restore fertility to their soils. And they're using an inoculated version where the biochar is essentially acting as refugia and habitat and to some degree food for the microbes. And they've had very, very impressive results using it. We have a little biochar stove. We've made some ourselves in the yard. I think it's one of those things that is one of the elements that should be in a regenerative farming toolkit that could be more or less applicable depending on the supply, what you have available to actually char. And what biochar is, if folks don't know, is it's basically taking organic matter and essentially doing a low oxygen combustion pyrolysis on it and basically blowing off the volatiles and basically having fairly clean carbon in the end. And that can be used as a soil amendment, and it can really help spur microbial life. And so it's one of the pieces that could actually be very useful in these kind of exercises. And it has a very good water holding capacity, which is probably why it works very well in arid regions. But it's also been very successfully applied in the tropics, where you can grow a good supply of things to char fairly rapidly. But there's a chapter that goes into that a little bit. So I think at this point I'd like to invite you all to come and get books and get them signed. I'd be happy to entertain more questions if people have them at the book signing. And again, I just want to thank you all very much for coming out and helping me celebrate the release of this book.